You are tuned to Iri-e-learning, and I am your host, Teacher. In this acids, bases, and salts lesson, we will examine the preparation of salts. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to identify an appropriate method for salt preparation based on the solubility of the salt. It is important to keep in mind that the method used to prepare a salt depends on whether that salt is soluble or insoluble. Therefore, we need to recap the solubility of salts. It's good to know which salts are soluble and which aren't. As summarized in this table, we see that nitrates and hydrogen carbonates are all soluble, and chlorides, bromides, and iodides are all soluble except for the lead. Chlorides, bromides, and iodides would only be partially soluble in hot water, and chloride, bromides, and iodides of lead and silver are insoluble. Now, for sulfates, they're all soluble with the exception of calcium and silver sulfates, which are partially soluble in water, and barium and lead sulfates are insoluble. Carbonates, only ammonium, potassium, and sodium carbonates are soluble. All the other carbonates are insoluble. As a matter of fact, any compound that starts with the name sodium, potassium, or ammonium, they are always soluble substances. We will begin with the preparation of insoluble salts. So our question is always, is the salt to be prepared soluble or insoluble? And since we're dealing with insoluble salts, then the answer to that question is no. So when we're preparing an insoluble salt, we use what is called the precipitation method. This involves mixing two solutions that contain the ions of the insoluble salt that we want to prepare. So one solution would have the cation and the other solution would have the anion. When the two solutions are mixed, a solid is formed, and this solid is called a precipitate, hence the term precipitation method. The solid formed is filtered, washed, and dried to give the sample of the insoluble salt. The precipitation method uses the double decomposition reaction. For example, here we have a reaction between two solutions, silver nitrate, AgNO3, and sodium chloride, NaCl. And note that the state symbols are AQ for aqueous solutions, meaning they're dissolved in water. In the double decomposition reaction, what we have is the exchange of ions. Say, for example, the exchange of the anions. So the silver takes the chlorine to form silver chloride, and the sodium takes the nitrate to form sodium nitrate. Recall from the solubility table for salts, which we reviewed earlier, we saw that silver chloride is an insoluble salt, and hence the state symbol solid, because a precipitate of silver chloride is formed, and it's in fact a white precipitate. This precipitate is suspended in a solution of sodium nitrate, and we know it's a solution because the solubility table tells us all nitrates are soluble. So we'll take a quick look at the process of preparing the insoluble salt silver chloride in the video that follows. In this activity, we will be preparing an insoluble salt using a double decomposition reaction. We will be reacting two colorless solutions, one being silver nitrate, AgNO3 aqueous, and the other sodium chloride, NaCl aqueous. Next, the two solutions are mixed. Notice the immediate formation of the white precipitate as the sodium chloride solution is added to the silver nitrate solution. The precipitate formed is the insoluble salt. Here is a closer look at the reaction mixture. In this double decomposition reaction, silver nitrate solution, notice the state symbol AQ for aqueous, reacts with sodium chloride, also in solution, and forms silver chloride, the white solid or precipitate that is suspended in a solution of sodium nitrate. The next step is filtration. Here is a setup of the filtration apparatus. This is the filter funnel. The filter paper is folded and seated inside the filter funnel. The filter paper traps or collects the insoluble salt from the reaction mixture. The beaker is placed below the filter funnel to collect the filtrate. The filtrate is the liquid that passes through the filter paper. Observe that the filtrate collected in the beaker is a colorless solution and the filtrate is the sodium nitrate solution. The residue, which is the white precipitate of silver chloride, is trapped in the filter paper. The precipitate is then dried to obtain a dry sample of the silver chloride. Next, we are on to the preparation of soluble salts. In the preparation of a soluble salt, we use the neutralization method. That's when an acid reacts with a base. Now, there are two possibilities. Is the base soluble is a question we're going to ask. If yes, then we use what's called the neutralization reaction using an indicator, and that method is called the titration or volumetric analysis method. And then what we would do, it would involve evaporating and cooling and drying the crystals. However, for this preparation of the soluble salt, we will actually address that method when we get to the lesson on titration. So our focus will be on what happens when the base is not soluble. And so when the base is not soluble, we add excess base to the acid, then we filter to remove any excess base that did not react. Then we evaporate the filtrate, cool and dry the crystals. And the resulting crystals would be a sample of our soluble salt. The video that follows shows the preparation of a soluble salt from an insoluble base reacting with an acid. In this activity, we will be preparing a soluble salt by the process of neutralization using an insoluble base, namely copper 2 oxide, which is a black powder. The insoluble base is reacted with warm sulfuric acid. The sulfuric acid is warmed to speed up the chemical reaction. Recall that a neutralization reaction involves an acid reacting with a base to produce salt and water as the only products. We start by adding excess copper 2 oxide, the insoluble base, to the warm sulfuric acid and stir the warm mixture for about 2 minutes at intervals. The insoluble base is added in excess to make the acid the limiting reagent in the reaction. This ensures that all the acid is used up in the reaction and there is none remaining to contaminate the salt at the end of the process. Let us examine the reaction that has taken place. The sulfuric acid H2SO4 solution has reacted with the insoluble base copper 2 oxide, which is the black powder, to produce a blue solution, and the blue solution comprises of copper 2 sulfate and water. The next step is filtration. The reaction mixture was transferred to a boiling tube and left to cool in a rack for a few minutes. Observe that the unreacted black copper 2 oxide powder was settled to the bottom of the boiling tube and a blue solution is formed. The suspension is shaken slightly before filtering. The filtrate, the blue solution, contains the soluble salt copper 2 sulfate. The final step involves evaporation and crystallization. The filtrate is slowly evaporated to a concentrated solution and then cooled to allow for the crystallization of the copper 2 sulfate salt. We can observe that as the water slowly evaporates from the solution, that the volume of the solution decreases and the color of the solution becomes a darker blue. Observe the formation of the crystals of the copper 2 sulfate salt at the bottom of the beaker as the solution cools in the air. The crystalline sample of the copper 2 sulfate salt is then scraped onto blotting paper and allowed to air dry for a few hours. Observe the needle-shaped appearance of the blue crystals of the copper 2 sulfate salt. Let's do a quick lesson summary. Salt preparation depends on whether the salt is soluble or insoluble. The precipitation method is commonly used to make insoluble salts. Neutralization reactions are used to produce soluble salts by adding excess base or acid or using the titration method. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Which salt is best produced using the double decomposition reaction? A. Sodium chloride, B. Barium sulfate, C. Ammonium nitrate, and D. Silver chloride. The answer is B. Barium sulfate. And this is the case because barium sulfate is the only insoluble salt given as an option. Question 2. What is the general name given to a solid formed after mixing two aqueous solutions? A. Powder, B. Putty, C. Precipitate, D. Filtrate. The
The answer is C, precipitate.
Question 3. An alkali is reacted with an acid to produce a soluble salt. Which method is best used for the preparation of the soluble salt? A. Precipitation method. B. Titration method. C. Synthesis method. D. Double decomposition. The answer is B, titration method. Remember that the titration method is used for a soluble base, which is an alkali, reacting it with an acid.
Question 4. Select the statement that accurately describes a base used for making a soluble salt by the neutralization method. A. The base must be soluble. B. The base must be insoluble. C. The base can be either soluble or insoluble. D. The base must be soluble and added in excess to the acid. The answer is C. The base can be either soluble or insoluble. Question 5. Which salt is best prepared by the neutralization method? A. Sodium chloride. B. Barium sulfate. C. Lead iodide. D. Calcium carbonate. The answer is A, sodium chloride. Remember, soluble salts are produced by the neutralization method, and sodium chloride is the only soluble salt given as an option.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.